Okay, good morning, students. Today we are going to see chi-square test for goodness of fit. The formula was given here. The chi-square, you note down the symbol. The chi-square is equal to summation I varies from 1 to n OI minus EI the whole square divided by EI, where OI is observed frequency, EI is expected frequency, and degree of freedom is n minus 1. So, if some experimental data or observed data was given with some frequency, then you can go for chi-square test. So, please remember the formula. The chi-square is summation I varies from 1 to n OI minus EI the whole square divided by EI, where OI is the observed frequency, EI is the expected frequency. So, you have to apply the chi-square test whenever the frequency of the data was given. Here the question asks, the following figure shows the distribution of digits and numbers chosen at random from a telephone directory. Digits and frequency are given here. We have to test whether the digits occur equally frequently directly. First, we have to set H0 and H1 for the problem. The H0, you have to write it as the digits occur equally frequently in the directory. In H1, you have to write the digits does not occur equally frequently in the directory, because the question here is you have to check whether the digits occur equally frequently in the directory. That is the question. So we are setting H0 as digits occur equally frequently in the directory. In H1, we are setting that it does not occur equally frequently in the directory. Next, we will continue how to do the second step. Step 2, because we have to write the observed frequency. The observed frequency is the frequency which is given in the question. Because it is given that 1026, 1107, 997, 966, 1075, 933, 1107, 972, 964, and 853. This is the data given in the question. This is the observed frequency we are having. So if you add these values, that is, if you add all summation OI, you will get it is equivalent to 10,000. Just you add all the values and see that you will get 10,000. Now we are going to find out the expected frequency. This is the observed frequency. So mathematically, how will you find out the expected frequency? So you have to divide this value by 10. 10,000 divided by 10, because we are having 10 observations. So you will get 1,000. 1,000, 1,000, 1,000. So I am writing the expected frequency as 1,000. After finding the expected frequency, you have to find out the value OI minus EI, the whole square, okay, divided by EI. What do you mean by this? First, you have to subtract 1026 minus 1,000. So you will get 26, right? 1026 divided by 1,000 minus 1,000. So you will get 26. The 26, the whole square, divided by 1,000. So you will get 0.676. The next value, how will you do? 1107 minus 1000. So you will get 107. You have to square that value and you have to divide the value by 1000. So you will get 11.449. And here 997 divided by 1000. So you will get 3. The 3 the square, which is 9 divided by 1000. So you will get 0.009. Similarly, if you proceed, you will get these values 1.156 and then 5.625, 4.489, 11.449, 0.784, 1.296, 21.609. So, if you add all those values, you will get 58.542, which gives you the chi-square value. So, if you add, you will get chi-square is equal to 58.542. Your chi-square values, you are getting us 58.542. Now, you have to compare this calculated value with the table value. So, in step 3, I am going to find out the table value. Before that, we have to find out the degree of freedom, which is n minus 1. There's 10 minus 1, which is 9. So, in chi-square table, you have to see under 9 degrees of freedom. So, your table value is 16.919. Okay. And in step 4, you compare these two values. That is the calculated value and the table value. The calculated value was greater than the table value. Therefore, I am rejecting H naught, which means that the digits does not occur equally frequently in the directory.